What's up guys, welcome back to the channel. Today on this video we'll be explaining and also apply the quotient rule. I hope you guys will be able to understand this. I've already made videos on other two rules, your chain rule and your product rule. If you want to know about those rules, go to the playlist section. There are videos on that. I made a playlist on those rules. Now guys, if you are new on this channel, I will advise you guys to subscribe to the channel, click the bell notification so that whenever I upload a video you can able to see the new video. And I'm planning to do a previous question papers, so you don't want to miss those previous question papers when I upload the videos on them. All right guys, so this is one of the rules that we use to differentiate functions. So the rule, where do we actually use this rule here? We use it when we have two functions that are dividing each other. Remember, quotient basically means division. It's a result of a division, guys, right? So let me just show you what I am talking about. Let's say we have y and then we have two functions. Let's say this is f of x divided by g of x. So this is the function. Let's say this function is given to you this way, so you must differentiate. In order to find the derivative of this function as a whole, you must be able to identify the function on the denominator and the function on the numerator. And so in order for you to find the dy over dx of this function, now what you need to know is the following formula. So the following formula, you start by differentiating or find the derivative of the f of x, which in this case is our numerator. So remember, you can write it as prime f of x, and then you multiply it with the function g of x. This time around, it is not differentiated, so it's going to be multiplied by g of x. Right, now from there, this is going to be subtracting instead of addition, so it's going to subtract. So what's going to happen now on the other term, on the second term of this here, you're going to differentiate the other. So meaning this time around, f of x, it is not differentiated. You're going to take it as it is, and then you multiply by the derivative of g of x. Guys, do not swap this. Do not differentiate on this term. Do not differentiate g of x and leave f of x. Do it exactly as it is. This is a very specific formula here. Then from there you divide. From there you divide g of x. Then that's this g of x here, you square it. So guys, that's how you do this, or that's how you apply this formula here. I hope it makes sense, but I'm gonna do one problem where we will be able to apply this function here. Now let me just write one function here. Let's say we have y is equaling to 3 natural log x over, let's say this time around it's over, let's make it e, and then let's make it 3x to the power of 3x. Okay, I think this is fair enough. As you can see guys, here you have your f of x. We know that your f of x is equaling to, just do this, your f of x, which is the numerator, is going to be 3 natural log x. Remember that. And then your g of x in this case is the one that are on the denominator here, which is going to be equaling to e to the power of 3x. So you have this, right? Then you need to find the derivative of these guys here. Now let's find the derivative of f of x. So if you find the derivative of f of x, which is going to be f of x prime. This is going to be, remember this is a natural log, so it's going to be 3 over x. Guys, I made videos about deriving the natural logs or finding the derivative of the natural logs with the formulas and everything. Go to this here, this video that will pop up here, and watch if it so happens that you don't understand the derivative of the natural logs. But if you do, then it's fine. Okay, so this is a f of x prime of the f of x. Now let's find the derivative of g of x. Now the g of x prime here is gonna give us, let me just close here, it's gonna give us 3 e 3 to the power of 3x. Again, guys, if you don't understand how this came about, I made videos explaining the equations or the formulas that we use to derive the exponent, because that one is actually an exponent function here. All right, guys, go and watch that video there. Okay, now let's continue from here. So you managed to differentiate f of x and g of x. So these are the derivatives for both. Now it's time for us to apply this equation here, or this formula here. All right, I'm gonna do it here since we don't have enough space this side. So your dy over dx for this one here that we have, we just have to substitute. Now remember, you substitute with the derivative of f of x. So what is the derivative of f of x for this one? It's gonna be 3 over x, then multiply. So now we multiply by g of x, but in this case now, g of x, what is our g of x? Our g of x is gonna be e to the power of 3x. So you write e to the power of 3x, and that's it. And then here you do what? You subtract. Now on the second term, on this numerator, we have f of x. So what is our f of x? Remember, f of x is going to be 3 natural log x. So it's 3 natural log, let me just put it here, minus, it's going to be 3 natural log x. So this is your f of x, not the derivative of f of x. Now multiply by the derivative of g of x. Now the derivative of g of x is gonna give us, or we have 3 multiplied by e to the power of 3x. So this is gonna be 3 multiplied by 3 to the power of 3 to the power of 3x. Right, now we divide everything here. Remember, now on the denominator, what do we have here? We're gonna square g of x. So what is our g of x here? So our g of x is e to the power of 3x. Then we do what? We square it. That's it, guys. That's how you do it. Then you can continue here. If you continue, let's say dy over dx, hopefully this won't take too much time. Obviously you're going to have 3 e to the power of 3x over x, then minus, and then we're going to have if you multiply 3 multiplied by 3, what is it that you're going to get? You're going to have 9, and then we can say multiplied by e 3x natural log x, all this divided by divided by, if you can see there, we have the exponent that are multiplying each other. So this is gonna be e to the power of 6x. So this is it, guys. Right, this is not the end of it. You can continue and take out the common factor on the numerator, and let's see what's going to happen and simplify it. But we are actually done differentiating. We're just simplifying here. So if you can look at the numerator here, the common factor here is 3 and e to the power of 3x. So if you take out 3 and e to the power of 3x, we're gonna be left with what here? We're gonna be left with 1 over x. And this side we're gonna be left with what here? We're gonna be left with 3 natural log x, right? And then this is gonna be divided by e to the power of 6x. Now if we divide there, this is gonna give us 3 multiplied by remember this and that, they're gonna divide, guys, by the way. Okay, and then we have 1 over x minus 3 natural log x over, just write over. Now this is gonna give us what is our answer here? This is gonna give us e to the power of, if we to the power of 3x. There we go. So this is it, guys. This is our final answer. I hope you guys managed to get this one here. I know it was a bit long, but if you can pay attention, let's look at this part here. This is the part, in fact I would advise you to stop here if possible, but this is the part that is most important, the substituting of the formulas here. Guys, I hope this was very useful. If you so happen that you didn't understand, you can rewatch the video over and over again, because I assume that in fact I'm confident that I explained to my level best, and I'm sure that you understood. But if you did understand, guys, you can like the video, subscribe to the channel, and also share the video to your friends. Also leave a comment if there's anything that you like to share on this video. By the way, guys, thank you very much, guys, for watching. Do not forget to like the video and also subscribe. At the end of this video there will be a playlist that will appear, so you can click on that playlist to watch other rule of differentiation. Thank you very much, guys. Till next time.